everyone, I'm Dr. Patel and this is the first video in a series on big data and machine learning. Big data is set to revolutionise the way we live and the way we do business. We are exposed to as much data every single day as a 15th century person would be exposed to in their entire lifetime. The whole world is being recorded as a digital footprint every single day. In 2020, there are 40 zettabytes of data. That is the equivalent to every single grain of sand in the world multiplied by 75. That's a lot of data. The data processing in 2015 and 2016 was more than the entire data processing done in the previous 3,000 years. That's the data explosion. The data explosion can be illustrated through a number of graphs. If we look at this one, we can see the annual size of the global data sphere growing exponentially year by year. The amount of genetic sequencing data at the European Bioinformatics Institute more than doubles every single year. But the billions of terabytes produced every single year by the SKA telescope will dwarf our datasets in genomics and climate science. The revolution is digitized, and we can see the surge of interest in big data since 2011 due to Google's archive of search terms. Big data is blowing up all over scientific research, popular culture, and our everyday life. A simple search on Nature, an oracle for the creme de la creme of scientific research, produces thousands and thousands of articles on big data. These range from big data in climate change, the challenges of big data in healthcare, artificial intelligence, big data, and clinical trials. It is everywhere. In our everyday lives, data is collected constantly, and this can illustrate the main difference between the data now and data in times gone by. Let's go back to the 15th century. In 1408, if I wanted to acquire the data of location, for example for Richard III, I would need to follow him around, manually writing down with a quill every location he was and the time he was there. Fast forward to today, for anyone with a smartphone, their current location is an entry in a database on probably Google's server, whether you have GPS enabled or not. That means, for example, Kim Kardashian's location at any point in time is recorded and logged. But why is this data useful and how can we use it? I'm going to use an example I've taken from Kenneth Kuki's TED Talk on big data, because I think it illustrates this concept excellently. Let's look at pies in America. What's America's favourite pie? If we look at the sales of frozen pies in America, then we can conclude that America's favourite pie is apple. However, once we've made this conclusion, shops start selling smaller pies. Rather than selling large 30cm pies, they're now selling much smaller 11cm pies. Now when I look at my data, apple moves down to 4th or 5th place in the ranking of favourite pies. Why? It turns out that apple is everyone's second favourite pie. That's why if you have to buy a large pie, you go for apple to keep most people happy. However, when you buy smaller pies, everyone can pick their actual favourite. You don't have to share anymore. We have more data. We can see something we couldn't when we had smaller amounts of data. More data can let us see more, it can let us see different, and it can let us see better. But what is big data? In its purest form, big data is used to describe the massive volume of structured and unstructured data that is so large it is difficult to process using traditional techniques. It's new because of the datafication of the world. As the world's information moves online and is digitized, analysts can start to use it as data. Everything you do online is stored and tracked as data. If you read a book on Kindle, it generates data about what you're reading, how fast you read it, etc., etc. It's not just about how big the data is, but it's also all the different types: text, social media posts, likes, audio, video, search logs, etc., etc. But what makes data big? When thinking about big data, we should think about the 7 V's. Volume. Big data is big. With the dramatic growth of the internet, mobile devices, and social media, the data associated with those has grown as well. Velocity. In addition to getting bigger, the generation of data has gotten faster, as well as organizations' ability to process the data. Variety. In earlier times, most data could be captured and stored neatly in rows and tables. In the big data world, data comes in unstructured formats. Variability. The meaning of words in unstructured data can take different meanings dependent on their context. Veracity. This refers to data quality issues, as data comes from many different sources. It deals with exploring a dataset for its data quality and systematically cleaning the data to be useful for analysis. Visualization. Once data has been analysed, it needs to be presented in a format for the end users to understand and act upon. This all sounds great, but how do we actually use big data? That's where machine learning comes in. An algorithm is a mathematical formula run by software to analyse data. Machine learning is a branch of artificial intelligence. It involves throwing data at a problem and letting a computer figure it out by itself using an algorithm. Let's use an example to explain. We need to look back to the 1950s to a man named Arthur Samuel from IBM. He popularized the term machine learning in 1959, and he created one of the first successful self-learning programs. This was the Samuel checker playing program, a very early demonstration of artificial intelligence. So the story goes that back in the 1950s, Mr. Samuel plays checkers against the computer, and he won. And he won again, and he won again. The computer at that point only knew the rules of the game, whereas Mr. Samuel knew strategy. So he wrote a small program that scored the probability that a given board configuration would lead to a winning board or a losing board after every move. He plays again a few more times, and he wins, and he wins, and he wins again. However, then he gets the computer to play itself to collect more data and increase the accuracy of its predictions. Then he plays again, and he loses, and he loses again, and he loses again. The machine has exceeded Mr. Samuel's ability at a task that he taught it. This encompasses the idea of machine learning. In more recent times, in 2016, Google DeepMind published an article in Nature detailing that they had created a computer program, Alphago. This program had mastered the game Go, a full decade before it was predicted that computers would be able to do this. In chess, on average, there are 20 possible moves for a given board configuration. In comparison, for Go, it's 200 moves. It is highly complex. The number of possible configurations of the board is greater than the number of atoms in the universe. It is a much more intuitive game. Alphago has an unprecedented record of beating the European champion in Go 5-0. It uses deep neural networks, more on this later in the course, that are trained by a novel combination of supervised learning from human experts at the game and reinforcement learning from games of self-play. This leads us nicely on to the different types of machine learning. The first is supervised learning. This involves modeling a set of response variables based on a set of explanatory variables. The machine should identify which of these is important and build a model that makes accurate predictions of the response variable given explanatory variables. The second, unsupervised learning, looks for patterns and structures in datasets that are often large and highly dimensional. In this case, we only have explanatory variables and therefore are not interested in prediction. The goal of unsupervised learning is to discover interesting things about the variables. Relevant questions include, can we find a way to visualize the data that is informative? Can we compress the data without losing relevant information? Can we find separate clusters or subgroups of observation that describe the structure of the dataset? Finally, reinforcement learning. This is a form of trial and error learning, where input data stimulates the algorithm into response, and where the algorithm is punished or rewarded depending on whether the response variable was the desired one. Let's look at some more specific examples. A research group analysed genetic data from 3,000 individuals at 500,000 positions in the genome. The individuals were collected from different countries in Europe. Before the study, it was not clear as to what extent populations within continental regions exist as discrete genetic clusters, where the alternative is a genetic continuum. It was also not known how precisely you can assign an individual to its geographical location on the basis of the genetic information alone. The group looked at how much structure was present in the dataset to assess the similarities and differences between individuals in the different populations. This figure shows the 2D projection of the principal component analysis, or PCA, performed on the dataset. PCA is a type of unsupervised learning. We can see how well the arrangement of points correspond to geographic location. This plot was only constructed using the genetic data, with no prior knowledge of the locations of the individuals. Yet the plot is able to uncover a map of where the samples came from. This approach of giving the computer and saying, you figure it out, has led to huge advances. One example is in cancer screening. The computer was able to separate the groups into those that had cancer and those that did not, but also identified more variables that could be included in cancer detection that were not already in use. Another example of machine learning in the real world is in basket analysis. When a customer goes through a checkout online, the information on items purchased will end up in a large database. This can be analysed to determine specific behaviours and patterns. For example, if I bought a toothbrush, how likely would it be I would buy toothpaste? This can lead to personalised advertising and customers receiving offers of the products that they are interested in. A similar example is the Netflix algorithm, which predicts what you might like to watch next. But what about problems with this? We are not always good at handling the data we collect. One of the biggest fears is the punishment for predictions. This would be where people are punished for crimes they are predicted to commit, not crimes they have already committed. A kind of algorithmic criminology. There is already location data, but what if this included data about your personality, data on your education, data on your credit score? What if it also included your biochemistry and the likelihood that you would have aggressive or angry thoughts? There could be algorithms that predict what you're about to do. It also speaks to the Cambridge Analytica scandal. By using your data from social media and your online presence, what you buy, etc., a company builds a picture of who you are. In the same way Netflix predicts what you might want to watch next, it builds a picture of your political preferences. It determines whether you could be influenced to change your mind about who you vote for, and if so, targets you with specific ads to influence your decision. And you have no idea. We just keep accepting terms and conditions and cookies, not those kind of cookies. The big data age is not going to be a question of online privacy. It's going to be a challenge of safeguarding free will and choice. That battle has already begun. To summarise, big data is revolutionising everything around us. More data allows us to see more, to see different, and to see better. It is defined as having high volume, high variability, and can have problems with quality. Machine learning helps us make the most of big data, to make predictions, and to understand the pattern and structure of data. This has been applied to countless areas, and is used every day in our personalised advertising as soon as we open our mobile phone. It is making groundbreaking advances in healthcare, in medicine, in business, the list goes on. The big data age will not be a question of privacy, but it will be a challenge of safeguarding our free will and our choice. I really hope you enjoyed this video. And next time we'll be learning how to use R so we can start making use of big data and machine learning.